So now, just explore a little more particular type of force called um, hydrogen bonding. Um, it's kind of a specific type of dipole-dipole bonding. So for instance, if I were to take hydrogen fluoride, I'll draw the Lewis structure. Now remember that fluorine is our most electronegative element out there. So it's totally greedy. Probably hydrogen really wants to have those electrons, but fluorine really wins out. So it's almost as if the electrons never hang out with hydrogen. So the hydrogen in this molecule kind of feels lonely. And so what it may do is it may become attracted to a non-bonding pair on another hydrogen fluoride molecule. And so again, the stronger this bond, the stronger the higher the melting point and boiling point, so on. And the strength of this bond is related to difference in electronegativity. One of the most important molecules that does hydrogen bonding, again, and I'm sure you've heard this in biology, is water. And because water has its unique shape and it forms these hydrogen bonds, it does a lot of interesting things. Because of its shape, when it forms a crystal in ice, actually that ice becomes less dense because of the pattern it has to hold. Less dense than water. So this allows ice floats on water. Incredibly important in Maine when people like to go ice fishing. Because if ice did not float, basically ice would would form at the bottom of a lake and then eventually fill the entire lake and the whole thing would just freeze over. However, if the top just freezes, it kind of just provides some insulation, and so then the water underneath doesn't freeze, and that's why fish can still keep going on. So, just a couple of unique properties of liquids that are related to these attractions. One is viscosity. And that just is the resistance of a liquid to flow. So one way to measure viscosity is basically by having a little narrow tube and pouring your liquid in, and the time it takes for it to flow out, actually probably flow out, not just drop out. That's one measure of viscosity. Another measure of viscosity is if you were to take your liquid, pour it in a container, and then drop a steel ball in, and then however long it takes for that steel ball to sink to the bottom is a measure of viscosity. One of the things that impacts viscosity is sort of the shape of a molecule, particularly with organic compounds that can form these long chains. So you can imagine if you have this long chain and then you have this short chain, if you have a whole bunch of these long chains, they can get all intertwined and tangled up. Whereas you have these short chains, they're probably not going to get all tangled with each other. So this compound would have greater viscosity. And what we have seen is that as temperature goes up, again, we know that kinetic energy goes up, and when kinetic energy goes up, attractions are broken down. So if attractions are broken down, then we experience liquids will have less viscosity. Another unique property of liquids is surface tension. You probably see this whenever you look and you see that meniscus. Well, there are two different things that are going on that are causing that meniscus. Surface tension refers to the energy required to increase surface area of a liquid. The reason this happens is because molecules at the surface are more tightly packed together. So we also have sort of two types of forces that are related to surface tension. So we have cohesive forces, which refers to the forces when molecules of a substance stick to each other, or molecules of substance stick to themselves. And adhesive forces, where molecules of a substance stick to a container.